be the link to the slides. For anybody listening in, it's at mountainmath.ca/GIS_day_2020, all lowercase, and that should get you to the slides, and they will stay up after.
Got it. Thank you.
All right. So really what I want to talk about is CensusMapper and StatCan data in R. So in more modern data science, really, we have people working mostly in either R or Python, typically both. So those are languages that are well suited to data science. People that come more from a stats background often tend to work with R. People that come from a programming background usually tend to work more with Python. But it really, at the end of the day, doesn't really matter that much nowadays anymore, which of those two you work with. And a lot of the methods, in the end, what sort of sits behind them is kind of the same. But this is the two ways of how modern statistics mostly is done. So we've moved away from a lot of the traditional platforms that people have used in the past.
Right.
And so, yeah, R is open source and free, which is great. Yeah, so open source has the advantage that, yeah, you can easily share, add to it, just sort of build things out bit by bit. So let me start and continue here. So what we're going to do is we're going to start to explore census data, and we'll build a Canada and look at how to make a Canada-wide interactive map. So that's going to be the first chunk of this talk, where we're just going to do some mapping and that help us explore and understand census data a little better in the context of maybe our community or whichever part of Canada we're interested in. Then we'll look at how we can get this data into R easily in a form that we can start working with it, that we can start to do some basic analysis. And then we're going to pivot and look at one thing that's usually very interesting is looking at timelines. How have things changed over time? And that can be very challenging on census data because the geographies on which the data comes, the way it's cut up changes over time. So we need to find a way to make data comparable over time. And so that's how we'll end this talk. So to start up, really, let's take a look at CensusMapper. CensusMapper is really my solution or my answer to the question of how to make data more accessible. So StatCan in recent years has done a good job of making it easier to get census data and making it easier to pinpoint census data in a way. But traditionally, it's been very hard and still is to complete even fairly simple tasks like, say, how many children live near me, if that's a question we want to ask. So to do this, we're going to take a quick tour of CensusMapper and how this works. So down here is a link that we can click to get into. And hopefully my screen shares now. So what we have here is a map that shows us net migration. So what this means is we're looking at from one census to the next, in this case 2011 to 2016. Each group are still there that we expect to be there. So right now we're seeing the under 5-year-olds here. So if we look at Coburg, the under 5-year-olds, we'll see that we asked the question in 2011, somebody who was under 5 years old. In 2016, they're going to be 5 to 9 years old. How many of them, we compare them to the actual 5 to 9 years old in 2016 to saying, did we lose some? Did we gain some? What was the net migration in this age group? And so what we see here for Coburg is we gained some in the under 5 category, so that's why it's green. And if we look in a little further over here, where did we lose them? Well, in Peterborough or in Oshawa here, we'll see there's some areas where we lost some of those under 5-year-olds. And what we can do here is maybe click through. You can see there are some buttons here for different age groups. And we can see, well, if those under 5 came in, how about the 5 to 9? Some of them still came in. And then we lost some 10 to 14-year-olds. So 10 to 14-year-olds, they're going to be 15 to 19 5 years later. And there aren't as many there anymore than there used to be. And then if we go to the 15 to 19, we see the whole area basically lose them. Those are kids that will probably be in university the year after, or move somewhere else, leave their parents' home. And that trend continues. For people in their 20s, they're still dropping out. And then the 25 to 29-year-olds, those are maybe the parents of the under 5-year-olds, and they're coming back into those regions. And it's sort of in many ways the generational pulse that we see here of a city play out. And we can probably see this even more dramatically in Toronto if we zoom in here a little bit and play with this. Again, the under 5-year-olds. And so family formation happens in the center here. Kids get born. And as we go, they kind of move out to more outlying areas. And then once we come into the teens and beginning 20s, they stream back into the city center. And that's where family formation happens again. And then once we get into late 20s and 30s, those people leave and move out. So this is a very natural cycle that you can see in any city really playing out in Canada. And so going back to Coburg, what we can do on an interactive map here is we can also just check what is sort of the distribution that we see on the side here on the upper right-hand side. We can see how the under 5s till 14-year-olds are streaming in, and then the 15 to 24-year-olds are leaving in a 5-year period. And we can kind of see how that shapes this net migrations by age, how it shapes who comes in and who leaves. So how does one do a map like this in CensusMapper? How could anybody say, if this is interesting, but how can I look at other things? Well, there's a little tab here that says make a map, where I can play with. And I can either look at what other people have done. So I can look at the list of published maps. If I click on that, I get a whole list of maps that many different people have done that I can just select from. Somebody looked at, I don't know, it says Dravidian languages as mother tongue in 2016. There's one of them. I can click on this and see. Somebody probably interested here in the Oshawa region, maybe, or east side of Toronto, looked at this and made this map and colored it. So what we can do is we can just make a new map ourselves. And let's start with a 2016 map here. So there are different censuses to choose from. And we'll maybe start with a 2016 one and start a new map. That maybe zooming into the area that we're interested in. And we'll have to figure out what kind of variables we want to do. So maybe we can either explore variables here by clicking through the categories and opening them up, or we can just find one ourselves. So I don't know, what are you interested in?
We were interested here in food insecurity or energy poverty.
Okay, so yeah.
Or carbon sinks. So
okay, so neither food nor energy nor carbon is part of the census, but poverty is. So let's maybe have a look at that.
Good.
So let's look at low income. So we can help ourselves by searching in the search bar, low income. And let's see what we got here. We have different things here, prevalence of low income. And we have two different measures that we can look at. We have low income measure after tax, or the LICO low income measure, which is probably a better measure for poverty. And so let's have a look here. We can look at the prevalence. We can look at children. just 0 to 5 or 0 to 17, or we can look at overall or adults. Let's just maybe look at the overall prevalence. So we can click on that little icon that gives us the option to map this. And here we go. I'm going to move this a bit over to the side. This now maps the prevalence in low income. We can zoom in a bit to see what's going on here, rebalance the colors a bit, and we got a map here that tells us where we have higher and lower percentage of low income populations in Coburg. Maybe you want to style this a little bit, so we can go to the colors tab, where we want to have a couple more colors, choose maybe a reddish scale for low income, and reset the colors a bit. Maybe we want to change the cutoffs that we have here in terms of the percentage. Starting at the lowest cutoff here is maybe 1%, 2.5%, 5%, 10%. Make it 5, make it 0 0.7, 10, 12.5, 15, 20.
And
let's see how we're doing.
Yeah, could you explain briefly the purpose of the cutoffs? Like,
it's just it's going to be the gaps between those colors.
Okay.
So where do we distinguish between the light yellow to the next orangish yellow? So you can see it at the bottom in the color bar, how the colors are cut between, what's the boundary between the light yellow to the a little darker yellow, for example.
Yeah, good.
So we don't here have any area with 20%. The highest we get to is about 18% here in those regions. But that paints you a picture of roughly what things look like in the Coburg area.
Since I live in Coburg, one of the things we're emphasizing is ground truthing. So as I look at this, I can see that the depot is one of the things that we describe, and I can see that it's there. So the dark red, those two up in, they know the larger piece here. Yeah, so definitely that's an area where there would be high poverty.
That's always good to see that it kind of checks out. So yeah, and of course these maps are Canada wide now, so we can take this pretty much anywhere. Maybe we can zoom out a bit. And as we zoom here on CensusMapper, it changes the aggregation level. So now we see we only see the city overall here. In Peterborough, because it's a census metropolitan area, we see census tract level data still until we zoom out a bit more. And then we have it on a basis. So here we can see on a city level, poverty is much higher. In Toronto, it's 17% citywide, the low income metric. And this is something that you see for many reasons. One is you have students. University students are by definition low income. They probably don't have any. And so there are many reasons why some places have more than others. Just having a high poverty rate is not necessarily a concern, but it can be. And so this is something where if we wanted to be concerned about this, we can look into Toronto and seeing, well, where are these pockets? And we see some that maybe are university related, but we also see some that probably are not. And so we can look at this.
I know some of those neighborhoods are in low income.
Yes, and so and when we're looking at something like this here, it looks overly red. Maybe we want to, and looking at our histogram in the upper right, we see that there's many areas above the 20%. And so maybe what we want to do is just reset here our scaling so that it brings it out a little better. So that just moves our cutoffs that we defined to bin things in equally big bins here. It gives us a bit of contrast to see what is going on in Toronto. We also see areas with very low poverty in Toronto. So those will probably be areas that are dominated by single family homes in the inner city. So those are going to be very expensive. Poor people just basically don't have a chance to go there.
Can you overlay the type of residence, or is that not in the plan?
So overlaying things is tricky. What we can do is we can say, well, let's just have a look who lives in this area. Say we're interested in this brighter area here that has lower poverty. As we zoom in, now we see it at a finer level. And so we want to see who actually lives in this sort of central part. Maybe we have a hypothesis, and we can go back here and look at, oops, where are we here? We can look at, instead of looking at poverty, maybe we want to look at other demographics. Maybe we want to look at ethnicity. So let's go back here. Ethnicity is part of our census data. And we can look at ethnicity, ethnic origin. Let's look at visible minority. It's a bit simpler. How about we look at the visible minority population? So this is we want to map it here, not just the total visible minority, but as a percentage of the total. So share visible minority is actually quite low in this area. So that gives us some idea about the demographics, and we can keep exploring this way.
That's surprising because Toronto has such a high percentage of
non-visible minority, of visible minority. Yes.
Visible minorities, yes. I was searching for the right
That's
term.
right. In general, sure, but not in this area. So if we zoom out a bit again and we look, yes, it does, but they don't live in this particular part that we just zoomed in that had the very low income, low prevalence of low income. It also has a low prevalence of visible minority. Those seem to go together here in this particular area.
And then as
visible minority.
Yeah. As a statistician, what kind of hypotheses might you start out with to explore this further in terms of analysis?
It gets tricky because what really we're doing is here we're comparing aggregates, right? So the share of visible minority and the share of low income, and we see some patterns. But does that mean that visible minority people tend to be of more low income? We don't know that. That's a hypothesis we would form by looking at this. But to understand this, we probably would want to look at a cross tabulation. So this would be where the census can, where we'd ask specifically in the census, can you tell us the share in poverty by visible minority status, so that we can see it for those individuals. And so we can do a quick look at this for the census metropolitan area of Toronto by looking at the microdata, the PUMF data, the publicly available microdata. That probably goes beyond the scope of this talk, how to do this. It's not very difficult, but, or we can look on the census custom tabulations that are available, and there may be one that's already available for download that has it at finer geographic areas.
Yeah. The other workshop, Jens, that Alessandro and his staff are putting on with the map viewer does use the microdata, but they only have a few data sets, and it's mainly buildings, and but that's a start.
Right, but so the buildings data set is sort of different because it doesn't have demographics on it.
Mm-hmm.
But yeah, so those are great too, to add context to your data. Okay, so if you're logged in, which I am not right now, but if you're logged in, then what it also allows you to save and narrow. And maybe that's something we can do right now. I don't know if you're logged in or not, but if not, let's just log in here. And in my case, I'm just going to log in. And if you are not logged in, and if you don't have an account, you can just make one real quick. Let's try to make a map. And so if you make it
simple map or
2016 map, yes, so simple map it says, and you can search for low income. And there's one that says prevalence of low income. So if you type low income in the search bar, it should bring it up that really it just shows you the low income. And let's click the last one that says of the low income of the first part here that says prevalence of low income based on low income cutoffs after tax.
Yeah.
And there's a little icon, the little map icon on the right of that, the very right part of it. If you click on that, comes with a pop-up, and you should have your low income map. So yeah, so now you have your low income map. And if you go now to save map.
Okay, save map is.
You can give it a title. So it's the orange bar on the right here where you get simple map. You just change that to save map.
Save map, got it. Give it it's private.
It's private, that means only you can see it.
Coburg, and this is prevalence of what?
Just, you can write Coburg low income.
Low income.
For now, just you can change that later too.
Yeah.
And what you can do is you can now write some text. Usually a map like this, I like to say a map, many people see different things in the same map.
Right.
And so this gives you an idea of opportunity to guide the reader if you want to share this about what you see in the map or what people should pay attention to. Typically, people have some idea of why they make a map and what it does. And so this gives you a way to describe this.
So describe.
And, you can just write whatever text you want, what you see in the map or what you want people to see in this. And then you're set. And you can always come back to that and edit it. And you can set it to non-private, and then you can just share a link to the map. Right, so that was sort of the first part of how to make a map in CensusMapper and share it. So so you can set it, there are different map visibilities here. That once you set it to published, it'll be on that list. I do kind of cut off, if you don't write a map description, I won't show it there. Mm-hmm. But if you do write something in your map description, more than just a sentence, then it'll show up. Yeah, so if you're in your social science class and you're looking at things like, maybe you look at immigration, you can look at, well, where do the immigrants actually settle? And where they're from? How does it split up? So there are a lot of ways you can explore sort of socio-demographic factors in Canada. Okay. So let's move on to the next step and see how we could use this maybe for analysis. So before we do this, I want to go back to here on my screen, the net migration map that we had at the beginning. And I want to look at the Vancouver area, which is of course something that I'm familiar with. And what I want to highlight here is sort of three different areas. The city of Vancouver. So if I look at this, and I'm now focused on the bar graph on the upper right, I can see under 5-year-olds, so kids that were under 5 in 2011, there are few of them in 2016. They're going to be 5 to 9 in 2016, and there are few of them than I would expect. So after that, I see a net inflow of people, of age groups, and that's university age. In the beginning, it's older kids, but also then university age kids. So they're actually moving to the city. More of them show up than I would expect. And then I see an outflow again of those university students, this strong inflow that we see there. Somebody's got to leave. We just don't have enough space, or we don't build fast enough housing for everybody to stay. So then people kind of filter out again. And similarly, if I look at West Vancouver here, West Vancouver is quite interesting. The kids are coming in at high rates, but then university-age kids are leaving. But then, of course, we have the people in their 30s and 40s coming back in. Those are going to be the parents of the kids. And then we see people leaving again. So it's a different pattern. If I look at Surrey, Surrey is quite different again from Surrey. Everybody else, Surrey looks more like Canada. It's just everybody's coming in. It's just growing. So Surrey is growing much faster than the city of Vancouver. And so people are coming in and they're not leaving. At least, of course, there are people moving in, but the people moving in or moving away get replaced by people moving in. And there's no age group that is losing people.
Yeah, that's a good point. That's a good comparison.
And so let's go back to our slides. And what I want to do here is, often I like to say maps aren't analysis. They're sometimes a starting point just to explore data. They can be an endpoint to visualize the results of an analysis. But in between, we also have lots of other visuals and ways that we look at data. We already saw the bar graph on CensusMapper. But here what we can look at now is, how about the age distribution in each of these cities? And the net migration patterns that we've seen will have impacts on the age distribution. So Surrey looks pretty normal, just like Canada. If we're looking at it here, we have people of these different age groups. It looks like a fairly balanced age distribution. It thins out to the older ages, just like we'd expect. A few more women in the older ages than men. That's what we expect too, and that's pretty normal. If we look at Vancouver, on the other hand, it has this big bulge of people essentially in their late 20s. That's where it peaks. And that's really the university age population, but also then the young professionals. And that is city center would attract. So Vancouver is much more city center than Toronto is. Toronto, a city of over 2 million people, still is an important part of the region. But if I think of old Toronto, maybe that's the role that City of Vancouver plays in Metro Vancouver. And so those young professionals, some of them will have to leave. And that's what we see what's happening there.
Yeah, one of them is my daughter.
Yeah. And West Vancouver is sort of it kind of looks almost like Vancouver fits in there. It's whatever West Vancouver is missing, that's what Vancouver has. So I guess if you're a kid in West Vancouver in your 20s, you just don't want to be in West Vancouver. You're going to move.
Yeah.
Maybe to the city of Vancouver. So that's how these net migrations then find its way in just the age structure of a city. And so what I want to talk about is how to make a graph like this one at the bottom. Like, how can I take what I see on CensusMapper and then maybe find different ways to view and look at the data. So how are we going to do this? We're going to work in R here. That's how this graph was done. In fact, the code that you see here is what made this graph. There's a bit of magic hidden in this code, and I'm going to walk through this and see how we can get there. So R is an open source software, and there are several libraries that other people have written, open source libraries that can help us with working with this. So we're going to focus on the CAN census package, which is my package that ties into the CensusMapper API to acquire data for the Canadian census.
Jan, could you just briefly explain, because high school students won't know what an API is.
Okay, so an API is an application programming interface. It's fancy speak for a structured way in which I can query. So if I want to work and I want to make these kind of bar graphs here, what I need to have is a way to say, give me the data of all 5-year-olds in Surrey, the counts, and give it to me for the males and the females. How do I get that data? And so the API, the CensusMapper API, is a way that I can ask exactly that question and then get exactly that data.
Great.
So if I look at it here, for example, just to look at the code here, I have a list of cities. So those, so it says they get the age data here. It asks to get it from the 2016 census. CA 2016 is the internal code in CensusMapper for the 2016 Canadian census. Then I specify the regions that I want the data for. CSD is census subdivision or municipality. So in StatCan language, that would be a CSD. And I have a list of CSDs here, 3 of them. And those codes, I'll show you how to find them. Those are the internal StatCan codes for Surrey, Vancouver, and West Vancouver. And then I ask it to have to query the age data here. And that's hidden in this call that it grabs the age groups. So this is a way of how we query the API that then gives us the data we want. And so the package that we'll be using is the tidyverse package, which is just a way of, it's built on top of R that is convenient for data processing pipelines that we will use, and also for visualization. CanCensus is a way for us to get census data. Tongfen is a package that allows us to do cross-census comparison. And the SF package is a way that helps us work with geospatial data.
Got it.
And when you run this the first time in R, you might have to install these packages before. You just write install.packages and then the name of the package, and it just installs it. So let's see how this works. So the CanCensus package is my package that ties into CensusMapper. And there's a slight complication here. We'll need an API key to really use this data, and I'll show you how to find this. So let's just get started, and let's make a map. Maybe what we're interested in is the percentage of the population that moved. And to do this, I'll show you now how to get this data. So let's go and start the CensusMapper API demo that we have here. So the CensusMapper API, it's sometimes hard to find data. And let's just say we want to know in the city of Vancouver, where did people move from? So I can zoom in here and look at region selection, and I select now the city of Vancouver as a region. And for the variable selection, I'm interested in the percentage of the population that moved. And similar to what we have done before, when we already made a map, we can now go through here and look at mobility, and maybe look at the movers that moved, the number of people that moved in the last 5 years. And we also want just our base variable of the mobility 5, so we can compute a percentage. So those are variables we've selected now. We've selected a region. We can go to our overview. That tells us what are the variables we've selected, what are the regions we've selected. And then we can ask, well, what kind of geography do we want this on? As we've zoomed in on CensusMapper, we've seen how it gets finer or coarser. To select the data, we can look at the CSD level here, the city level, census tracts, or dissemination areas. So maybe that's what we'll do here.
Can you briefly describe the difference between those three? Like, I think we know what the subdivision, but getting down lower, people won't know what that is.
So let me just explain it here again on this map that we looked at before. So right now I see census subdivisions. So these are municipalities here. If I zoom in on CensusMapper, it switches automatically, in this case, to census tract. That's the region I see here. So you can think of this as small neighborhoods. They only exist within a census metropolitan area, the census tracts. So we won't find these for Coburg, but we will find them for metropolitan areas. As we zoom in more, we get, this might not be the best map to do this in. I gray it out when things don't exist. Let's make a published map here. So here I look at population density. I switched it out, so it's census tracts again. If I zoom in more, I get dissemination areas. So those are smaller regions here, as you can see. And if I zoom in even more than that, I will get census blocks. So these are very fine regions we see here right now.
And how many people are in a block compared to a DA?
So in a block right now here we have 57 in this one. Some have more. This one has 350. It varies, but it's on the range of maybe about 100. If I go to a DA, it's more like 700. Here I got 500, 580, 800 on this one. It really just depends. 800, that's roughly the range.
What's the criteria for determining the definition of these categories?
So StatCan every year goes in and they basically take the old fabric they had. They look at when new developments, for example, come in and a population grows, they might split it. They look at natural boundaries to determine how to best split it. Sometimes they ask for local input. They would ask the municipalities saying, hey, what should we do this year? You know what's best on what's happening here. Do you have any suggestions? And so these boundaries will be redrawn from census to census. Most of them stay the same, but a good portion of them will change from one year to another, from one census year to another.
So is that conversation Stats Canada has with the municipalities? Is it primarily with the planners, or?
It'll be somewhere with a planning department that they will talk to, just somebody who kind of understands how things change in the city. But they also, of course, have local people there that'll pay some attention to that themselves. So those boundaries will get redrawn a bit.
Mm-hmm. Thanks. That's a good overview.
All right. So dissemination areas that's what we see here is the finest geography that we get regular census data released on. If you look at census blocks, so that's this, we only get population, dwelling, and household counts.
Well, that's useful too, knowing.
Yes. And there are many uses how this can be used. How this can be used, even just to really, if I want to see just where in my dissemination area people actually live, it helps me filter these out. Looking, for example, here, I get some large areas of park where nobody lives. Mm-hmm. Once I go to the dissemination area, it looks like there's really, really low population density, but that's because the people that do live in there, they don't live in all these parts, and I might want to take them out.
Mm-hmm. Yeah, got it.
So, okay, so let's go back here. So I wanted to select what kind of region I want my data on. So maybe I wanted a dissemination areas here. So I select that. And here it gives me just the code that I can copy paste into CensusMapper that will get my data. Another option here that comes in is a way that I have to set my API key. Typically, I will do that in just my environment variables so that it's always there and I don't have to set it every time. But that's something I'll have to do. If you're logged in, it shows what your API key is. So now I'm just actually exposing my API key. I'll have to change that when I'm done with this. Yeah. But yes. So this code here, you can just copy paste it into R and it'll grab that data for you.
Okay, so that's the select level for download, and it's the second box. Is it? It's always set up this way, right? The way I'm looking at it now. Yes. So for me, if I grab that second box.
Yeah. Good. And the first box here just tells you to install the package, maybe to load the package, to set your API key, and you can also set a cache so that it's stored locally, the data, so that it doesn't have
with that
we download it all the time.
Yeah, so let's say I wanted to bring it into ArcGIS Pro. Could I do that?
Yes, so you can also just download down here at the very bottom. You can see you can just download the variables or download the geographic data.
Okay.
So you could download both of those and then you would have to join them in ArcGIS.
Okay, so the download the geographic data, that has the shape files, or?
That has the shape files, or in this case, it's going to be GeoJSON, but that's just fine for ArcGIS. And then the variables will just be a list of variables, and both of them have a common variable, so that they come with the geographic identifier, and you'll join them on that in ArcGIS.
Yeah. Okay.
Or you could also just grab the data from the call that's in R and then save it as a shape file if you wanted to. That's another way to do it.
Okay. How do you do that?
I can show you that.
Okay.
But here in this call, actually, if we're looking at this for a moment, it says the geo format is NA. So if you want to, in this case, it won't actually download the geographic data. Mm-hmm. And you can change that to SF, which is the internal format in R that we're using for geospatial data. And then it'll come with the geographic data.
Cool.
So let's go back. and see how this works out. So here I also have for people, if you wanted to live code right now, you can just grab this API key for the duration of this talk and work with it. But let's see how this works. We selected our data. So here's the get census call that I copy pasted. The only thing I changed is I added the geographic format to be SF because I want the geographic data. And I gave my two variables that I have here a name. The first one I called the movers, the number of people that did move, that live in a region that did move in the past 5 years. And then the base, which is just the number of people in that region that are 5 years and older. It doesn't really make sense to talk about somebody having moved in the past 5 years if they aren't even 5 years old yet. So those are taken out here. Then I compute, then I make a map here. So I plot, take the data, I want to plot it. How do I want to plot it? I want to fill each polygon with a color. What color do I want to use? Well, the share of the movers. So that's what I compute here. The movers divided by the base. So geom_sf just tells us I want to draw those geometries, these simple features here, SF geometries. The size, I just want to have a thin boundary around them. And then I tell them I don't want any lat long coordinates on there. That's what the coord SF does. So I don't want to display what's the latitude and longitude as a scale on the X and Y axis here.
Right, okay.
I want to fill it with the Verdis color palette, which maybe looks nicer than the default. And I want to put labels there that are percentages. I give it a title and a caption, and that's it.
Yeah, that's...
So this is the entirety of what you have to write in code to make this map. That's at the bottom here.
Wow.
So, of course, I live in the city of Vancouver, you live in Cobourg, so maybe we want to make a map like this for Cobourg. So the only thing we have to change is we have to find what is the CSD identifier that StatCan has for Cobourg.
Could we do it for all of Northumberland County, which has 7 municipalities?
Yes, we can do that too. So let me maybe show you how you would do this. So let's start over here. I'm going to reload this. And we're going to go over to Cobourg. There we are. And we want to do it for all of Northumberland County. So let's go to region selection. So we want to go to the census district level. And there it is, selected.
Yeah, cool. Yeah.
And again, we select our variables as we want it. So let's maybe do that real quick too, since I still remember where they are. We have the movers and the base. And we go back here. And again, we want to do it for dissemination areas. And there we are, here's our code. So in this case, we want the CD of 3514. That is Northumberland County. So great. So really all that we need to do now is replace this regions list here with CD equals, what was it, 3514.
Yeah.
And that's it.
Yeah.
So unfortunately, I don't have that prepared. What I do have prepared is the one where we just change in Cobourg as a city.
Good. Yeah.
But it works the same way. So you can just drop that in there and that'll give you that, that data. So all I did here is I really did the same thing that we did before, except I don't do it all in once. I assign it to a variable called data. That's where my data is now. And then I do a plot and I assign the plot to a variable called G. And then I just output G here. But everything else is the same. And I get the map for Cobourg.
Got it.
Why did I do this and assign it to G? Maybe what I want to do is I want to add some layers to my plot. So I'm going to do this here. I have a library called Mountain Math Helpers. So that's things that I use a lot. For example, I want to add a water layer and a roads layer. and just add that onto the map. And I might want to also limit the view window. If I look at before, there was a lot of gray around and some areas that are quite large here. And it probably is okay to cut them off a little bit, like I'm doing here, depending what I'm interested in. So that gives me a nicer looking map. And but it's just some minimal styling, but it makes kind of a difference because now I can tell much better where's what just by looking at it.
Mm-hmm. Right, yeah, yeah. Railway, some roads.
Yeah,
And if you zoom in, do you get more detail, or is this just really kind
this
of
is just a static map. So this one here, you can't zoom, but that's a good question. What if I want to do that, especially in the beginning of an analysis? I probably want some interactivity. So let's see how I make an interactive map. So here is, I take the same data that I have, and I use a library called MapDeck that ties into the DeckGL library, which is built on top of Mapbox. So this is Uber's map library built on top of Mapbox that I'm now accessing from R.
okay.
And so what does that give me here? I take my data. I again compute the share, which is the movers by the base. I compute, it's cut off a little bit, the maybe a tooltip. I call it info here as a variable, and it's just the percentage of the share. I simplify my geography a little bit on a web map. If I show it like I do on slides here, I might not want the full detail. I want to cut some corners essentially on those geometries. Otherwise, it takes some time to load. And I only select the variables I'm interested in, the share and my tooltip. And I just specify that I want to have as tooltip my info variable here. I add some opacity, which is out of 255, so it's about a 2/3 opacity. I can still see the map below it, and I fill it by share. And that's it. So here's my map. I can zoom in, and I can explore these different regions. And on hover, I see my share of people that moved. So in this region, 53% of the population that lives there did not live at the same address 5 years earlier.
So that's the DA. When you say region, that's the DA.
That's the DA here that
Yeah.
I see. So in the interactive map is great to explore things, but it's also sometimes a good way to share just a small part. I might not want to share a whole CensusMapper map. I want keep people focused on a specific region, and I have more freedom to do exactly what I want if I make a map like this.
Yeah, that's good. So the map now is embedding the analysis, is telling.
That's right. And the way this works in R, which is actually quite nice, is that this code here that I wrote, it kind of outputs this map. And if I compile it to an HTML document, which is what I've done here, it sort of adds it in right here. I didn't do anything special to make the map show up here. It just sort of is the output of this code.
Mm-hmm.
So it's very easy to build a web page, say, that has this embedded automatically.
So do you, like we use WordPress for our website. So how would we embed it in a WordPress website? Is that another workshop?
That would be another workshop. So
Okay.
that still works, and you can do this. Yeah.
Okay. Yeah, that's very cool.
So
yeah, I've learned a lot. That's so what we need to do with this recording is get a couple of students, maybe like as a co-op position with Sustainable Coburg, and have them look at some things. Are in your gallery, are there other examples, or I guess we could look at the maps that are in the the ones that are shared publicly at the very beginning when you search for map?
So to round this up, I'm going to skip through the census timelines part. That's a bit tricky maybe, and I'm just going to gloss over this here.
Yeah.
But here's some resources that can help you go through this. So the first part is the slides. Of course, they're online here, but I can also just open them up on the to get the actual code. Oh, it's not up yet. I'll have to change that. but there's actually the notebook that made
All right.
this.
Yeah.
You can also, for examples, there are some on my blog that use the CanCensus package and some that use the Tongfen package for census timelines. So you can look at different posts there that have the code in there as an example. Or what you can also do is, if we go back to the CanCensus package here, I'm going to open this up, that has documentation on it. So here's an article of how to make a map that walks you through these things just like before. So here's a map that we can plot, different stylings, maybe also make an interactive map. And it has little code snippets that you can copy paste to get you started, or to do other type of things. How do you find data that you're interested in? Or yeah, just some additional data that you can look at.
Well, I suppose we could go in and pull the data out of the Alessandro's viewer, right? The map viewer, those building footprints? Or?
Right, so if you look at the building data there's just a download button. You can just download the entire thing, and then you can mix and match it with this data if you wanted to do that. So you would add the polygons and maybe overlay the location of schools.
Right, yeah. And then the other one in Ontario, they have the which schools offer the school nutrition programs.
That's right, and you can overlay that there, and you can see how that matches with demographic makeup of neighborhoods, and maybe look at some inequities built into this.
Yeah. Oh, this has been excellent. I really appreciate you doing this. And now I got my work cut out for me. Try it out and then get some co-op. I think what would be good is for me to get a co-op student or even a classroom that is teaching this. I'm trying to think in the Ontario curricula. Have you looked at BC's curricula, or has anybody from the school districts out there worked with your CensusMapper? Do you know, or?
I know that there's some students have worked with it, but I think it's mostly just student driven. Somebody found it interesting, and started playing with it.
Yeah. Where's that being stored? And
right, so the server is in Toronto. It's just a cloud server that has the data. It's encrypted, but yeah. So in many ways, the sign up is a bit of a barrier, but it gives you a way, of course, to edit your own maps later on. Without sign up, you can't do that. And at the same time, for the data download that you need this API key, part of that is just that it's a server that I have running. It's $20 a month. And I just want to make sure it doesn't get hit too hard. So I do put a limit on how hard, there's some people that come around and they think, oh, this is much more convenient than getting data from StatCan. And then they just download enormous amounts of data for their own purposes. At some point, if you really want the entire census, you should probably get it from StatCan. The big advantage of this CensusMapper and the API is that you can pinpoint it to say, give me just Cobourg, just these variables. Which you can't really do with StatCan.
So you have set a limit. So there's nothing like if a student came in and wanted to do that, they wouldn't be able to do it because you set a limit on the traffic.
Yeah, they can't download the entire data set.
Yeah.
I mean, I can upgrade their account, and I do that usually when people email me saying, hey, I have this project and I'm running into limits here. And then I'll just upgrade their account. It's fine.
Yeah. Well, you're doing a good, it's amazing what you're doing. You're paying for this. $20 a
well, yeah. I think it's mostly the time effort that went in. And in many ways, I'd like to polish it up quite a bit. But right now, I just can't justify the time to do that.
Yeah. Well, you deserve certainly a lot of recognition because not many would do this, right? At the side of the desk.
I mean, mostly it was done to help myself to explore the data, but then also to help myself do analysis. So these tools that I build around that have really sped up my work and made my own work more efficient. But it's great if it's useful to others too.
Yeah. Well, just in closing, what would your advice be to a senior high school student that is thinking about, okay, so what kind of skill set am I going to need? We hear a lot about data analysis, data visualization, data administration, but I really can't sort of see myself in some kind of a role when I go on and get a post-secondary degree, or even if I don't, if I go into the workforce. What would your advice be to that individual?
I think one big advice I have is like 80% of my time is not actually dealing with data science things, but it's more actually just understanding the data. So you do need a sort of a broad background that you actually can understand where the data comes from, what are the quirks in the data. You'd look at the survey question, think about how do people actually answer this, because it doesn't necessarily reflect what you think it means in general. So understanding the data and understanding how it came about and is a really important part of the analysis. And that usually requires a pretty broad background that anybody really can have. If you have a liberal arts background, that'll help you a lot just to understand this. Also, what you need to understand is the relevance of the data, like how to apply it. What's the right question to ask? You can always take a data set and run some analysis, but it's useless unless it actually answers a question that is valuable.
Mm-hmm.
So this is something that's, I think, really important. Of course, being able to do the analysis is important too. So that does require some quantitative skills, some mathematics, not necessarily deep mathematics, but a deep understanding of basic mathematics.
And what in particular, the algebra or the analytic geometry or
I think
trigonometry?
for the mathematics, sort of in data science, linear algebra is really important. So basic, I mean, algebra, yes, but also linear algebra, if you want to do more in analysis, is just very important. Some basic calculus is probably good too. And that gets you very far already. You don't need advanced math.
No, that's good. And then last question, because I know you're probably anxious to have breakfast, is Stats Canada published an article last year, and they were musing about moving away from the 4-year census and trying to leverage administrative data.
Right.
And they got in trouble because one of the things they were talking about is getting access to bank information rather than having people, submit this in their tax returns. What?
Right. So moving to administrative data is great because it just gives a much more complete picture. So we've already done this in the past census, where we moved to like nobody actually had to give information about their income. It was taken automatically. It was people's data was linked to their tax returns on an individual level, and that was used to determine people's incomes. So we have much higher quality income data in this past census. People could ask fewer questions, which made it easier to fill in the census. The cost is, of course, that this linking kind of seems a bit spooky. And it does happen in some back rooms. Essentially, you can think of it as like a StatCan has several levels of privacy where they silo the data where it can't really come out in any way. And so this is something that does happen. When it comes to the banking data, so there is a lot more that's going on. Income is only one part of the equation. Wealth is another one. How much assets do people have? And that is, we don't really have good data on this. There's one survey out there that is irregular that captures some of this, but banking data can help a lot. I feel like that discussion that happened there was a bit misguided. The big companies, private companies, they already have this information, right? This banking information is already available to many big companies. And the question is, do we want to have government statistical agency to have this data to give out statistics on this? So this is not the government having of it. It happens, these kind of things happen in silos and only get released in a way that is where StatCan thinks that there is very low risk of privacy, of sort of tracking something back to individuals. But that way government at all levels and also the public has some of that information too. And so the question is, as big companies have it already, is this something that maybe is useful? And I would tend to say yes. StatCan is very good about siloing this data when they link it and then releasing it in a way that makes it very unlikely that you can link it back to individuals. And it's not something that government has. It's really just happens in some StatCan silo.
Yeah, well, that's certainly a bigger topic and an important one. And we'll start with the basics and then come back, and maybe in a year's time, we'll have a conversation around Canada's privacy laws and the pan-Canadian framework for data privacy and using machine learning and all that. Cool.
And that is changing too. The US Census has now moved to differential privacy, which is a different kind of privacy framework as what we are using here in Canada. And I think it's unavoidable that Canada will move in this direction too, just as a mechanism to release data that has a higher guarantee on privacy in the age of machine learning.
Yeah.
You're muted, I think.
Yes, and on that note, seems to be, it's not just the trade war between China and the US, it's also the big trading blocks that are trying to determine the standards for privacy and trade with the World Trade Organization. So you have Europe, China, and the US. Europe with its general data protection regulation, but of course, you can't apply that to the whole world. So there are all those issues that are being negotiated. Really cool stuff. Important for young people to know context and to have the basic liberal arts and the math and in order to be able to deal with all these challenges. So thanks very much, Jens, and
my
enjoy
pleasure.
your breakfast.
I will.
Bye for now.